On July 1, 2025, the Atlas Survey Telescope in Chile reported an object that defied all conventional classification, a comet coming not from our system but from the cold depths between the stars. Pre-discovery images later traced its path back to mid-June, confirming that this was no routine comet. 3I Atlas travels on a hyperbolic trajectory, a straight-line path that will take it in and out of our system. It does not orbit the Sun, but is simply passing through. Its speed is staggering, tens of thousands of kilometers per hour, far faster than any familiar solar system object. As the comet draws nearer, space observatories have begun to turn their powerful eyes toward it. The Hubble Space Telescope recently captured detailed images revealing a teardrop-shaped cocoon of dust emanating from its nucleus. From these observations, scientists estimate the nucleus to be between 320 and 5.6 kilometers wide, a broad but critical range. Meanwhile, NASA's SPHEREx mission has joined the effort. Between August 7 and 15, the spacecraft collected infrared data that might help reveal what 3I Atlas is made of and how it reacts as it heats. Other missions, including Hubble, Webb, and ground-based telescopes, continue to monitor its progress through the inner solar system. But this comet's journey is not just a scientific curiosity, it's a challenge. According to ESA, the European Space Agency, Mars orbiters such as Mars Express and the ExoMars Trace Gas Orbiter are tracking 3I Atlas as it swings close by, offering perspectives no Earthbound telescope can. Their view may reveal outbursts, telltale jets, or even unexpected behavior, signs that this interstellar wanderer might be more than just a frozen rock.
As 3I Atlas ventures closer to the Sun, its tail becomes the subject of intense scientific scrutiny. The coma, the cloud of gas and dust surrounding its nucleus, shows signs of activity far beyond what typical comets display. Spectroscopic studies, using instruments like those on the James Webb Space Telescope and other observatories, reveal a surprising chemical composition. According to early analyses, carbon dioxide dominates the gas emissions, with significantly less water than in many other comets. This CO2-rich outgassing suggests that the comet's nucleus may be unusually cold or composed in a way different from typical solar system comets. Observations from ground-based telescopes align with these findings. Gemini South, for example, has documented increased brightness and a growing dust halo as 3I Atlas heats up on its inward journey. At the same time, space probes like ESA's Solar Orbiter and NASA's Parker Solar Probe are analyzing how solar wind interacts with the comet's ionized material, revealing complex patterns of charged particles streaming away. These interactions are more than just spectacle. They offer clues about the structure and behavior of this interstellar object. Some scientists suggest that the release of material might not be random. There are hints of jet-like features, focused and repetitive, which could indicate internal vents. But these features do not match the chaotic outgassing of typical comets. They are organized, persistent, and unusually stable. If these jets are indeed stable, and if they are aligned in certain ways, they could imply underlying processes that are far more sophisticated than simple solar heating. Yet no definitive proof of artificial propulsion has emerged, only questions. Compared with other interstellar visitors, such as Oumuamua and 2I Borisov, 3I Atlas seems to push the boundaries of what we thought we knew. Its tail behavior, chemical output, and reaction to solar radiation may force astronomers to expand their models of what comets can be.
As the data pour in, the scientific community and the public alike grapple with the implications. Speculation runs high. Is 3I-Atlas simply a comet or something more extraordinary? Online, theories flourish. On space science forums and social media threads, commenters raise the notion of a technological comet, suggesting that its organized jets and unusual composition hint at non-natural origins. According to some Reddit users, the silence from major space agencies is fueling suspicion. Why aren't all images and data being shared? Others point to what appears to be an embargo on information, suggesting that NASA and ESA are withholding key imagery as the comet approaches its closest point to the Sun. But the agencies respond with caution. NASA has stated unequivocally that while 3I-Atlas's behavior is unusual, current data support a cometary nature, and there is no confirmed evidence of artificial control. ESA scientists emphasize that their instruments, from Mars orbiters to interplanetary missions, are simply being used to collect data while the comet is in its most active phase. Some researchers argue that the most sensible explanation remains the geometric alignment. As the comet's orbit aligns with the inner planets and the Sun, dust from older outbursts may remain in orbit, producing optical effects that look like strange tail behavior. It's a complex dance of solar radiation, dust inertia, and perspective. Still, not every expert is convinced. The debate has become a crucible for scientific humility. Extraordinary speculations must be measured against extraordinary evidence. For now, the most grounded response is this: let the data speak.
Whether 3I Atlas proves to be a routine comet or something altogether more enigmatic, its arrival marks a milestone in space science. For astronomers, its chemical signatures, especially the high ratio of carbon dioxide compared to water, could redefine our understanding of interstellar ices and the environments in which these objects form. JWST's observations may provide the clearest compositional map of any interstellar comet to date. Polarimetric studies are already revealing unfamiliar patterns. One recent analysis reports extreme negative polarization, a polarization behavior not seen in typical solar system comets. Near-infrared spectra from other observatories suggest large water ice grains, mixing with dust in ways that tie 3I Atlas to both cometary and asteroid bodies. Looking ahead, space agencies may use what they learn here to prepare for future interstellar visitors. ESA's planned Comet Interceptor mission, for example, could be sent to study an object like 3I Atlas at close range. Meanwhile, next-generation observatories, both on Earth and in space, are being optimized to catch and analyze these rare travelers. For the wider public, the tale of 3I Atlas resonates deeply. This is not just a scientific opportunity, but a reminder of our place within the galaxy, a small planet orbiting a modest star visited by a messenger from a distant system. Its dust, its jets, its chemistry, all of these carry something bigger than themselves, the story of cosmic connection. When 3I Atlas finally recedes into deep space, it may leave behind more questions than answers. But those questions will shape how we explore, how we understand, and how we imagine what lies beyond.
In the unfolding story of 3I Atlas, new figures and images are arriving daily, sharpening the portrait of this interstellar visitor. Latest verified data now show that the comet is more active than first estimated. According to official materials published by NASA and the European Space Agency, or ESA, the object is now entering a phase of rapid change. Ground-based and space-based observatories report a steady escalation in dust outflow and jet activity as 3I Atlas approaches its perihelion later this month. Spectroscopic data from the James Webb Space Telescope, or JWST, indicate that the comet's coma is rich in carbon dioxide, with a CO2 to H2O ratio far higher than known solar system comets, one of the largest measured for an interstellar body. These findings suggest that 3I Atlas may have formed under very different conditions, perhaps near a CO2 ice line in its home system or under a high-radiation environment. That has profound implications for planetary science. Meanwhile, observations taken during the September lunar eclipse show the comet's coma developing a subtle green hue, a color shift not previously seen with typical comets and possibly a clue to unusual chemical processes. As the comet moves behind the Sun from Earth's perspective for a brief solar conjunction, certain space-based instruments such as ESA's Jupiter Icy Moons Explorer, or JUICE, are tasked to maintain contact and gather data where ground telescopes cannot. Amateur astronomers are also preparing. When the object reemerges in early December, dedicated campaigns will target it from multiple continents and in multiple wavelengths, coordinating with professional observatories. In short, 3I Atlas is not just passing quietly, it is actively evolving before our instruments. Every new image, every fresh spectrum, adds a piece to a puzzle that may challenge our assumptions about comets, interstellar objects, and the history of planetary systems. For viewers of this documentary, this update is an invitation. Stay tuned because the next act of this cosmic drama is imminent, and the data may change our view of comets forever.